Alright, welcome to the Pre-algebra 9.5 video. We're talking about the distance and midpoint formulas today. Okay, so the first thing I want to talk about is the distance formula. And I've given us a triangle here on a coordinate plane so that we can kind of get ourselves into this concept of distance. So let's say I call that point A, B, and C. And I said, what's the distance from A to B? Probably do what comes natural and count, right? Well, I said 1, 2, 3, 4, 5, 6, 7. Right? To get from A to B at 7. But what if I said from B to A? Well, you might say, well, it's the same. 1, 2, 3, 4, 5, 6, 7. And you would be correct. Now, even though you're moving in this direction, you're still moving 7 spots. It's kind of like it's -7. But either way, from A to B is 7, from B to A is 7. It's like saying from Austin, Texas to Peoria, Illinois, where I'm from, is 1,000 miles. But also, if you go from Peoria to Austin, it's still 1,000 miles. It's not negative 1,000 miles, right? So we're just talking about distance. We talk about distance in terms of positive. So from A to B, or you could say the line segment AB, the distance of that is 7, okay? But what if we want to know the distance from A to C, right? So the interesting thing about going from A to C is that I'm not just going one line at a time, right? This is at an angle, okay? So really, what is the distance there? Because we notice that this, one little line segment on your graph paper is that long, okay? But from there to there is a different distance. So, how can we do that? Well, we have what's called the distance formula. All right, and there you have it, the distance formula, okay? A little complicated, so let's just walk through it real quick. D, which stands for distance, okay, is equal to the square root of, and then everything that comes next is under the square root symbol, okay, under the radical. Parentheses, x2 minus x1 squared plus, in parentheses, y2 minus y1, in parentheses, squared, okay? Or you could think of it as these are the difference of the x-coordinates of the points squared plus the difference of the y-coordinates of the points squared. Okay, so how does that help us? Well, let's work through a problem. All right, so we're going to find the distance between the points 6, 3 and 5, 7. So we don't actually need to graph them, but if it helps, we can. So let's just do that real quick. If I'm going to graph the point 6, 3, and I'm going to call that point A and then point B. So point A is at 6, 3. So over 1, 2, 3, 4, 5, 6, up 1, 2, 3. And then 0.57 over 1, 2, 3, 4, 5, up 1, 2, 3, 4, 5, 6, 7. Okay, so we're finding the distance between those 2 points. That's A and that's B. Okay, and I can't just count because they're not on the same grid line. So I need to use the distance formula. Okay, so again, the distance formula. D equals the square root of x2 minus x1 squared plus y2 minus y1 squared, okay? So what does that mean? Well, if we got x's and y's in there, and we have to remember that our points are made up of x and y coordinates, okay? So point A is 6, 3, right? So what's the x coordinate and what's the y coordinate there? Well, 6, 3 is 6 is the x and 3 is the y. Now it's the first point that comes in our sentence, so I'm going to call it x1 and y1. And then here on point B, 5, 7, that's an x-coordinate and that's a y-coordinate, and I'm going to call that x2 and y2, okay? So I'm going to go to my formula and say, okay, I'm going to plug in what I know. D equals the square root of x2 minus x1 squared. Okay, so what's the x2 and what's the x1? Well, I labeled. Go back to my points. What's the second x-coordinate? It's 5. What's the first y-coordinate? It's 6. So I'm going to put in here 5 minus 6. And then I'm going to add to that, in parentheses and then squared, y2 minus y1. Well, let's see. y2 was 7 minus y1, which was 3. So 7 minus 3. And so now what we can do is really just use this formula to solve for D. Okay, so D is going to be equal to the square root of. Well, okay, remember square root's like a grouping symbol, so I need to do what's inside. And inside the square root symbol, I have exponents, I have parentheses. So now I need to do what's inside the parentheses. So 5 minus 6 gets you -1, and then we're going to square it later. Plus 7 minus 3 is 4, and we're going to square that. All right, cool. So D equals, let's keep on going. -1 squared is like saying -1 times -1, which is +1, plus 4 squared is 16. Okay, so now we have D equals the square root of, well, I can do 1 plus 16, which is 17. All right, so, can I simplify the square root of 17? Well, 17 is not a perfect square. It's not like 100 or 25 or 16. And there's no perfect square that multiplies by something else to get you 17. Therefore, I am done. Okay, so if the answer said leave it in square root form, you could do that. Or you could find the square root of 17, which is 4 point, approximately, so I'll do approximately equal to 4.123. How about that? Okay, so what does that mean? Well, it means that that distance right there between B and A, or A and B, is the square root of 17 units long, or it's approximately 4.123 units long. And as always, I'm really bad at numbering these. This was item number 1, the problem we just did called item number 2. Move on to item number 3. Okay, so I want you to find the distance, so pause the video and try this. Find the distance between the points 11, -2, and then 7, -5, okay? 11, -2, and 7, -5, using the distance formula, which you now have. All right, so remember the distance formula. I'm going to run through this pretty quick because I want to give you time to do it. x2 minus x1 squared plus y2 minus y1 squared. All right, so what is x2 minus x1? Well, let's see. x2 is going to be the second x coordinate. All right, so here is an x coordinate, and here's an x coordinate, and this is the first one, this is the second one. Okay, so x2 is 7 minus x1, which is 11, plus y2 minus y1 squared. Y2 is, well, let's see, where's the second y coordinate? This one right there. Where's the first one? Right there. So y2 is -5 minus y1, which is -2. So I'm going to do another parentheses in there. All right, so what we get now is 7 minus 11 is -4 squared plus, let's see, this next one's going to be kind of complicated. -5 minus -2. Okay, so I'm going to write that over here. -5 minus -2. Well, we know that minus a negative becomes plus a positive, so that becomes -5 plus 2, which we know to be -3. All right, so let's see. D is going to be equal to the square root of -4 squared. That's -4 times -4, which is positive 16, plus -3 times -3 is positive 9. All right, and then we get, well, 16 plus 9 is 25, and that's really great. Why? Because, well, guess what? 25 is a perfect square, so what's the positive square root of 25? It's 5, okay? So 5 units should be the distance that you found there. And if you graph those points, okay, then you would say, well, let's see, approximately. I'm just going to rough sketch this really quick. 11, -2, so, goodness, over 11, down 2, see, and then 7, -5, over 1, 2, 3, 4, 5, 6, 7, down 1, 2, 3, 4, 5. Right there, that distance between those 2 points is 5 units. All right, so next we're going to talk about the midpoint formula, okay? So what do you think of when you hear the words midpoint? Well, mid sounds like middle, right? And point. So we're actually going to find a middle point, okay? So a point that's in the middle of two things, all right? So we're going to be really talking about line segments here. We know a line segment looks like that. You have a point and another point connected by a line, okay? So we're going to be finding the point that lies in between 2 points. So let's take, for example, item number 5 here. We're going to take the 2 points 3, 8. And how about -9, -4? And we're going to find the midpoint between those 2 points. So we know we could graph both those 2 points on a coordinate plane, and they would form something that look like that. And so we're going to find the point that's directly in between those 2 points. So here's our formula. All right, and m is going to stand for midpoint, of course. So m equals, let's see, x1 plus x2 divided by 2. All right, so let's work on that. And if you notice, this thing's in one big parentheses because we're actually finding, like I said, a point, right? And there's a comma in the middle, so we're going to end up with one number there and one number there. So x1 plus x2, well, let's see. That's the first x value. That's the second x value. So let's add them up. It's like saying 3 plus -9, and we divide that by 2. All right, now let's talk about the y's. Well, that's the first y coordinate. That's the second y coordinate, so we're going to add those up, 8 plus -4, and divide those by 2. All right, so let's keep on moving. I'm using a bunch of colors here, so I apologize if that's confusing. 3 plus -9 is like saying 3 minus 9. 3 minus 9 is -6, and we're going to divide that by 2. And then 8 plus -4 is like saying 8 minus 4, which of course is 4. I'm dividing that by 2. All right. So now -6 divided by 2 gets you -3. 4 divided by 2 gets you 2. And you have just found the midpoint between those 2 points. And to prove it to you, let's graph both original points and then the midpoint. All right, so we have our coordinate plane. We're going to graph the 2 original points. Then we'll graph the midpoint and see if the midpoint really is in between those 2. All right, so the first point is 3, 8. Let's graph him. Over 1, 2, 3, up 1, 2, 3, 4, 5, 6, 7, 8, right there. And the second point was -9, -4. All right, so let's see. Over -9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Down 1, 2, 3, 4. Right there. Okay. So now, what's the midpoint? Well, we think it's -3, 2, so let's just kind of check. So if I graph the point -3, 2, it means I go over -3 up 2, putting me right there. I'll do this one in orange. Okay. So let's see. If I connect our 2 original points with a line, let's see if that midpoint lies in the middle. And you know what? It's right there. Kind of got hidden by the line. There's our midpoint. Those were our 2 original points, and yeah, that looks like it's pretty smack dab in the middle, okay? All right, so lastly, I just want you to pause the video. I want you to try on your own finding the midpoint of those 2 points, and then play the video when you're done. All right, so we remembered that the midpoint is equal to x1 plus x2 divided by 2, comma, y1 plus y2, and then divided by 2 as well, okay? Now, another way you could think of this is the average of the x coordinates divided by 2, comma, the average of the y coordinates divided by 2, okay? So let's see. x1 plus x2. Up here, x1 plus x2. x1 is -7, plus x2 is 5. Divide that by 2. Y1 is 1, plus y2, which is 11, and divide that by 2. All right, so now what we have is -7 plus 5, so it's -2. Divide that by 2, comma. 1 plus 11 is 12. Divide that by 2. So let's see, m equals -2 divided by 2 is -1. 12 divided by 6 is 2. Your midpoint there is -1, 6. All right, that's all I have for you guys on this video. Look forward to seeing you in class and talking more about distance and midpoint.